So welcome students to the lecture 2 of the topic plane. In previous lecture we tried to derive the equation of plane in various forms. In this lecture we have the very first topic, the equation of plane which passes through the intersection of two given planes. So before starting this article, let me explain the intersection of say two lines in 2D or in three-dimensional geometry. You might have understood this concept that if the two lines in two-dimensional geometry, either they intersect or they do not intersect. If they do not intersect, we call them parallel lines. But if they intersect, this is the point of intersection, right? So when two lines in two-dimensional geometry, if they intersect, their intersection is a point. Similarly, in three-dimensional geometry also, you might have studied in three-dimensional geometry the topic straight line. Either the lines that do not intersect, they are parallel, they are skew lines, but if they intersect, the intersection is again a point. So the intersection of line in 2D or in 3D is a point. But what happens when two planes they intersect? So suppose we have two planes. These are the two parallel planes. They will never intersect. But if the two planes they intersect? So suppose this plane intersects with this plane. It goes like this, the intersection, right? Or you can say that these are the two planes. So these two planes they intersect, and their intersection is a straight line. You can see that this is the intersection. Their intersection is a straight line. So we have two planes, say P1 and P2, and they intersect. Their intersection will be this line. This is the line of intersection. And now we are trying to find the equation of the plane which passes through the intersection of these two planes, means which passes through this line. In fact, it will not be a unique plane. We will have a family of such planes. I will explain again with the help of this notebook. Consider these two planes. This one is the first plane, this one is the second plane, and their intersection is this straight line, and we have this plane, we have this plane. So there are so many planes, infinite planes, which passes through the intersection of two given planes, right? So we are not going in detail. We will simply take the result that P1 plus lambda P2, you have to remember this, P1 the first plane plus lambda times P2 equal to 0 will be the equation of all such planes which passes through the intersection of P1 and P2. So if the equation of plane P1 in vector form is r dot n1 is equal to d1, the equation of plane 2 in vector form is r dot n2 is equal to d2, then the equation of plane through the intersection of these two planes will be r dot n1 plus lambda n2 is equal to d1 plus lambda d2. Right, and the value of this lambda will determine that unique plane. So we have a family of planes. By changing the value of this lambda will have different planes passing through the intersection of the two planes P1 and P2. So in this question we have to find the equation of a plane through the intersection of this plane and this plane. So the situation is same. We have two planes and we have to find the equation of a plane through the intersection of these two planes. But as you know, the intersection of two planes is a line, and there are infinite planes that passes through the line. So he has given us one more condition, that the required plane passes through the point 213. There is going to be a unique plane which passes through this point 213, and we are going to find its equation. So although the equation of the planes are given in vector form, but I personally feel we must convert these equations in Cartesian form. As you know, to solve this problem in Cartesian form is much simpler than to solve this problem in vector form. You will find so much difficulty using vectors in this type of question. So we can easily convert this equation of plane in vector form, from vector form to Cartesian form. So it will be 2x plus 2y minus 3z minus 7 equal to 0. this is the equation of the first plane in Cartesian form, P1, and the equation of plane 2, it's going to be 2x plus 5y plus 3z minus 9 equal to 0. So the equation of plane through the intersection of these two planes, you can easily remember this result, P1 plus lambda P2 equal to 0, right? So this is 2x plus 2y minus 3z minus 7 plus first plane plus lambda times the second plane equal to 0. So collect the values of x. So 2 plus 2 lambda, 2 from here and 2 lambda from here, x plus similarly y and similarly z. 2 plus 5 lambda y plus minus 3 plus 3 lambda z minus 7 minus 9 lambda equal to 0. So this is the equation of all the planes passing through the intersection of these two planes. But now we are looking for a particular plane which passes through this point. So as our plane passes through this point, so the equation of plane must satisfy this, this point must satisfy that equation of plane. So for that we'll be substituting x, y, z with this point 2, 1, 3. Reason being, this point lies on this plane, right? So we have 2 plus 2 lambda times 2 plus 2 plus 5 lambda times 1, then minus 3 plus 3 lambda times z, that is 3, then we have minus 9 minus 7 lambda equal to 0. From here we have 4 plus 4 lambda plus 2 plus 5 lambda minus 9 plus 9 lambda minus 7 minus 9 lambda equal to 0. Some values of 9 lambda cancels with minus 9 lambda, and we have from here we have 9 lambda, and in numbers we have 4 plus 1 6 minus 9, that is 3. 6 minus 9, that is minus 3, minus 3 minus 10, and here we have 10. So the value of lambda is 10 by 9. So for the equation of plane, we again have to substitute this value of lambda here. So we have 2 plus 2 lambda, lambda is 10 upon 9. This much times x plus 2 plus 5 lambda, lambda is 10 upon 9 times y plus minus 3 plus 3 lambda z. Instead of lambda we have this value 10 by 9, this times z, then minus 7 minus 9, again you have to put the value of lambda, that is 10 by 9, and simplify this. So on simplification you have the equation of such plane. So moving on to the next topic, that is coplanarity of two lines. What we mean by coplanarity of two lines is, suppose there are two lines which lie on a same plane. So these are the two lines which lie on the same plane. We say that these two lines are coplanar, right? And in space we can have lines which are not coplanar. It means there is no such plane on which these two lines will lie. If you try to find out a plane, there will be no such plane in which these two lines they lie. Actually we call them skew lines. You might have studied that in the topic straight lines. What are skew lines? The two lines which are neither intersecting nor parallel. We call them skew lines. And we can also call skew lines as non-coplanar lines. So in space we have three situations. So first situation is we have two lines which are parallel to each other. If say this is the situation, can we have a plane through which these two lines which lie on that plane, can we have a plane? So we can have that plane. You can imagine this plane, right? You can imagine this plane. These two lines, they are coplanar. So if the lines are parallel in space, suppose imagine this is these two lines are parallel in space, we will always have a plane. We will always have a plane containing these two lines. So if the lines are parallel, they are coplanar. If the lines are intersecting, if the lines are intersecting, again we can have a plane, right? If the lines are intersecting, we can always have a plane. So intersecting lines are coplanar, parallel lines are coplanar, and if the lines are neither parallel nor intersecting, then they are non-coplanar, and we call them skew lines. So here, how can we tell? We have just the mathematical equation of the two lines in space. How we are going to tell what is the condition by which we can say the two lines are coplanar or not? So the condition of coplanarity of two lines L1 and L2, these are the vector equations of two lines L1 and L2, and the condition that L1 and L2 are coplanar is if this condition is satisfied. So you have to remember this result. So if this dot product is equal to 0, then the two lines L1 and L2 are coplanar, otherwise they are not coplanar. So the question is, show that these two lines, they are coplanar. We are not going to check, we are just going to show that these two lines are coplanar, and from this article you know if this condition is satisfied, then the lines are coplanar. So we'll simply find the dot product and show that it is equal to 0 to prove that these two lines are coplanar. The condition which we have remembered is in vector form, but the given equation of lines are in Cartesian form. So very quickly we are going to convert them into the vector form. So this is your first line L1, and say this is your second line L2. So the equation of line L1, this Cartesian equation, we can convert it into the vector equation. For that we have r vector is equal to the passing point minus 3i plus j plus 5k plus lambda times minus 3i plus j plus 5k. So this is the equation, vector equation of line 1, and for the vector equation of line 2 we have the passing point minus I plus 2j plus 5k plus mu times the b1 vector, b2 vector minus I plus 2j plus 5k. I hope you know how to convert from Cartesian form to the vector form. Now we have, this is our a1 vector, this is a2 vector, this is your vector b1, and this is your vector b2. So now we have a1, a2, b1, b2, we will find a2 minus a1, a2 minus a1 vector. So a2 minus a1, minus 1 minus minus 3, that is minus 1 plus 3, 2y, 2 minus 1, that is j, 5 minus 5, that is 0 times k. So this is a2 minus a1. For finding b1 cross b2, for finding b1 cross b2, we have this b1, that is we have to evaluate this determinant I cap, j cap, k cap. b1 vector, components of b1 vector minus 3, 1, 5, components of b2 vector minus 1, 2, 5. From here we get 5 minus 10 minus 5i plus minus plus, then minus 15 plus 5 minus 10 plus 10 j, and finally we have minus 6 plus 1, that is minus 5 k cap. So we have a2 minus v1, we have b2 minus v1. So now let's see what is a2 minus a1 dot b1 cross b2. So let's see, if we dot product these two vectors, we have minus 10 plus 10 plus 0. So this thing is, this dot product is coming out to be equal to 0, and from the article you know if this thing is equal to the 0, then the lines are coplanar. So finally you have to write that L1 and L2 are coplanar. So students, the next topic is very easy, in which we have two given planes. Say r dot n1 equal to 0 be the first plane, and r dot n2 equal to not 0, d1 and d2. So two planes are given and they intersect, and we are trying to find the angle between the two planes, right? So suppose these are the two planes, right? So you can see this is the angle between the two planes. How we are going to find these two angles? Now understand this. Say this is the normal to the first plane and this is the normal to the second plane. So what I claim is the angle which the normal makes with each other will be same as the angle which the planes make with each other. So you can imagine this. This is the normal to the first plane, and this is the normal to the second plane. Now whatever is the angle between these two normals, same will be the angle between the two planes. So I repeat what I said, that the angle between the two planes will be same as the angle between their normals. So we simply have to find the angle between n1 vector and n2 vector. So from the topic vector algebra, you know how to find the angle between the two vectors. The angle between two vectors n1 and l2 will be theta, say. So cos of theta will be n1 dot n2 upon magnitude of n1 and magnitude of vector n2, and if we have to find the acute angle, then modulus of this thing. So if the two planes are given, it means the normal vectors are known to us, and we can simply evaluate cos theta. Then theta will be cos inverse of this thing, n1 dot n2 upon n1 magnitude, n2 magnitude modulus. So this angle theta is the angle between the normals n1 and l2, and it will be same as the angle between the two planes p1 and p2. From this article we are going to derive a very important condition in planes, that if the planes are perpendicular, then the dot product of their normals is equal to the 0. The case is p1 and p2, they are planes which are perpendicular to each other. So as you know, the angle between the planes is same as the angle between their normals. So if the planes are perpendicular, it means normals are perpendicular, and you know from the vector algebra that the condition for perpendicularity of two vectors, that if the vectors are perpendicular, then their dot product is equal to 0. So if the dr's of the normal to the first plane are, say, a1, b1 and c1, be the direction ratios of the normal to the first plane, and for second plane the dr's of the normal, say, a2, b2 and c2. So n1 dot n2 equal to 0, it means a1i plus b1j plus c1k dot a2i plus b2j plus c2k is equal to 0, and then we have a1a2 plus b1b2 plus c1c2 equal to 0. A very important condition for two planes to be perpendicular. If this thing is equal to 0, we can say that two planes are perpendicular, and otherwise also if two planes are perpendicular, it means this thing will be equal to 0. So you have to memorize this, a very important condition for perpendicularity of two planes. Now case 2. What if the planes P1 and P2 are parallel? Two planes in space that are parallel. So you can easily understand that the normal to the first plane and the normal to the second plane, if the planes are parallel, their normals are also parallel. That's why I said the angle between two planes is same as the angle between their normals. If the planes are normal, perpendicular to each other, their normals are also perpendicular to each other. If the planes are parallel, their normals are also parallel. So in that case, n1 will be parallel to n2. So the direction ratios of the first normal vector a1, b1, c1, they are going to be in proportion to the direction ratio of the second normal vector c2. So this is the condition by which we can say that the two planes are parallel. So question based on this article, angle between two planes are given and we have to find the angle between those two planes. So for that, as we know, the angle between the two planes is same as the angle between their normals. So first of all we will find the normals to the two planes and then we find the angle between those two normals. So for as far as the solution is concerned, first we will write this equation, r vector dot 2i plus j plus 3k is equal to 2. This is the equation of the first plane, and the second equation is r vector dot I minus 2j plus 0k cap is equal to -5. So this is the equation number 2. So this is your normal vector n1, the normal to the first plane, and this is the normal vector to the second plane. So if we have to find the angle between the two planes, we have to find the angle between their normals. And how we are going to find the angle between their normals? For that, the formula is cos theta is n1 dot n2, and in the denominator we have the magnitude of n1, magnitude of n2, and the absolute value of that. So n1 dot n2 you can easily calculate, n1 dot n2. For dot product we have 2 plus -2 plus 0. So the dot product is 0. So and what is the magnitude of n1 vector? So it will be square root of 4 plus 1 plus 9, that is square root 14. What is the magnitude of n2 vector? It is 1 plus 4 plus 0, that is square root of 5. So putting the values of n1 dot n2, n1 vector magnitude, n2 vector magnitude here, we have cos theta is equal to n1 dot n2, that is 0 upon square root 14 square root 5, the absolute value of that. But 0 upon any non-zero quantity is 0. So cos theta is 0 implies, when is cos 0? Cos is 0 at 0 degree. Cos is 0 when theta is 90 degree. So actually these two planes, they turned out to be perpendicular to each other, right? The last article in NCERT is the angle between a line and a plane. So for this, just imagine we have a plane and a line, and the line and plane, they intersect at a point, right? If the line is parallel to the plane, they will not intersect, but if a line and plane they intersect, their intersection is a point. Okay, so we are not talking of the intersection point, but we are now interested in this angle, the angle between the line and the plane. So I'll explain you this. So we have this plane and we have this line. This is the point of their intersection. So the equation of plane is, say, r dot n is equal to d, and let the equation of line be r is equal to a1, or you can simply say a plus lambda b. A plus lambda b be the vector equation of the line, r dot n equal to d be the vector equation of the plane, and we are interested in this angle theta. Okay, as you know, this vector, this normal vector n, it's a vector which is perpendicular to the plane, and the line is making angle theta with this plane. So since this is the perpendicular vector, so this angle will be 90 minus theta. These two angles, the angle which the normal makes with the line and the angle which the line makes with the plane, they are complementary angles. So we can easily find this angle. Why? We have the equation of this line and we have a vector which is along this line, that is vector b, and we have this vector n vector, reason being we have the equation of plane. So the angle between n vector and b vector is 90 minus theta, and we are interested in the angle theta. So what we can do is cos of 90 minus theta is n dot b upon n magnitude b magnitude, the absolute value of that, and cos 90 minus theta is sin theta. So theta will be sine inverse of this n dot b upon n magnitude b magnitude, the absolute value of that. So this is the formula for finding the angle between a line and a plane. So we can do simple problems based on this article. Okay, thank you.